folks, how's it going? Welcome to the day number 12. This is the May LeetCoding challenge. My name is Victor and I'm taking part in it. So if you're interested, please keep watching this video and make sure you hit the like button and subscribe. Let's get straight to the problem. Well, the day number 12, single element in a sorted array. You're given a sorted array consisting of only integers where every element appears exactly twice, except for one element, which appears exactly once. Find the single element that appears only once. So I believe the problem makes sense. There is an interesting and important note here. Your solution should run in log n time and constant space. So I see three different solutions to this problem, but they have different complexity. So the first one is pretty straightforward. You just take the hash map, you count the elements, and you find the element which appears exactly once. Pretty straightforward solution, easy to implement, but it's not constant space. The other solution, it has constant space, but it also has linear time complexity. So it's quite an interesting and tricky solution, and it's a real solution to another problem where the array is not sorted. You take an integer, you find exclusive OR for all the elements in this array, and the result is that single element. You may check why it actually works. I'm not gonna talk about this right now. So the solution that I'd like you to take a look at this video is binary search. So when you see log n complexity, the first time that probably comes to your mind is binary search. So let's talk about the binary search solution. Alright guys, let's see how binary search works here, how we can apply it. We have to find the middle element as usual in binary search. Then we have to look at the right pair of elements. In this case, the index of this middle element is even. In this case, it equals 4. So we have to look at the next element to form the right pair of elements. For instance, if it were here, and in that case it would be odd, we had to look at the previous element. So make sure you're working with the right pair of elements. Now, if you understand that, for instance, this is the right pair of elements, and you understand that these elements are not equal, so they're not equal, it means that we can find the right set of pairs here. All these pairs are valid, which means that we have to try to search the single element, the search element somewhere on the left side. So you have to find it here. Now in this example, the middle is here, and as I already just said, we have to look at the previous element, and this is the right pair of elements. And now these two elements are equal. These elements are equal, which means that somewhere in the left, I mean all these elements on the left side, they form the valid pairs, and we have to try to search the single element somewhere on the right side. So basically that's what we need to implement in binary search here. So I already wrote the code and made sure that it's accepted. I'm not gonna waste your time anymore. Now let's take a look at the code, and I'd like to comment some important things. So as you can see, as usually we create two pointers left and right, and we run the while loop. We have to stop when left meets right. At this point we find the middle point. So here we find the middle point, and this is the trick to not get the overflow. So it could be just left plus right over 2, but that might overflow. So now this is the super interesting thing. I just said that we need to make sure we're working with the right pair. So if this middle value, middle index, is even, this takes the next element. If it's odd, then it takes the previous element. So basically, if it's even, it it adds 1. If it's odd, it subtracts 1, which is exactly what we need. And that's just changing left and right, basically as I already described. So at this point we know that when left meets right, the answer should be here at the left position.